All right, welcome everyone. This is the Kronos OpenXR BOF. So we're going to be giving you a quick update and overview of the OpenXR standard, which is the standard for portable access to XR, that's virtual and augmented reality hardware. So we have some awesome speakers. Thank you everyone for volunteering to speak today. We have Ming Shen from PICO and Peng from PICO also, and Weiqi from Rocket, who has the best hardware right now. So I'm going to start just by giving a couple minutes level set on the current status of the working group, and then we'll get into more details on some of the roadmap. So, if you haven't come across Kronos before, we're an open standards organization. We're open for any company to join. We create royalty-free standards that are free for the industry to use. We have about 150 member companies. Around 30% of that, about 50 companies, are based here in Asia. And we're focused on low-level APIs for accessing hardware, GPU hardware for 3D rendering, compute acceleration, XR hardware. And over the years, we've brought 3D graphics onto PCs, onto mobile, onto the web, into immersive technologies. And now we have an up-to-date and kind of modern suite of APIs and languages: Vulkan for GPU, Slang, which is the modern shading language, SPIR-V, which connects Vulkan and Slang together, and Anari, which is a high-level rendering API. So OpenXR addressed a very obvious fragmentation issue in the industry a few years ago. Before OpenXR, we had a classic fragmentation problem where every hardware vendor of XR hardware was exposing the capabilities of their hardware through their own proprietary API. And so the software community had to port one-on-one to each new piece of hardware. And that was obviously a big limit on the growth of the market. With OpenXR, now we have all of the hardware vendors are agreeing on how they're going to expose the capabilities of their hardware. So software vendors can write once and run anywhere that supports OpenXR. So the hardware vendors win because they get a bigger library of software that runs on their hardware. And the software vendors win because they can ship their applications and engines across many more hardware devices. So everyone gets a bigger market and a bigger opportunity. OpenXR is shipping pretty much on all of the XR hardware that's out there, but there's one exception, notably that's Apple. They have their own APIs, but Meta, Rocket, Xreal, Canon, you can read them on the slide here. They are all conformant with OpenXR. Also, the engines that many of the applications use to create their applications also now support OpenXR as a backend. So OpenXR is definitely fulfilling the promise of XR portability. It's still a young API though. The working group was formed in 2017. OpenXR 1.0 was released 2 years later in 2019. We've just released OpenXR 1.1 in 2024. Because this was the first time we've tried to create an open standard for XR, there was some experimentation necessary. So in the early days and during the days of OpenXR 1.0, there were quite a few vendor extensions. Every Kronos API is extensible, and we welcome vendors to ship new and experimental functionality as vendor extensions. If the working group likes the functionality and the market accepts that functionality, then we often bring that into a Kronos multi-platform standard. But in the early days of OpenXR, a lot of experimentation was necessary, so we have quite a few vendor extensions. And that will continue because we're still at the beginning of the XR journey, but the working group now is working hard to consolidate that experimentation into vendor extensions. And you're going to be seeing some of that in the presentations that come up in just a moment. OpenXR 1.1, the big part of it was the Spatial Entities extension, the first step in expanding OpenXR from being just a hardware capability API into being an API that lets applications understand the environment around the user and actually understand the user themselves through hand and body tracking, for example. And we're going to see that capability now begin to expand with future versions. More hand and body tracking again. We'll see more details coming up in the presentations. And we're also working on how to bring multiple applications into an XR environment. So you're going to be seeing a lot of new developments out of OpenXR over the next few years. We're expecting probably the cadence of new releases. Now we're in the groove with 1.1. Probably every 18 months or so, you'll see a new version of the specification, but with extensions coming between the specification core releases to keep the forward momentum. So that's enough for me. Let's get into the interesting stuff. So Ming, Shen, do you want to join us?
Thank you, everyone. Hello, I'm Ming Shen from PICO. I'm very excited to be here to talk to you about the amazing evolution of OpenXR in 2025. OpenXR has come a long way in recent years, and in this presentation, we are going to explore all the cool changes and improvements it has brought. So let's dive right in. Let's kick off with the big picture. In 2025, OpenXR has evolved around two core ideas: how much it boosts user experience and how mature its industry standards are. We can see 5 key upgrades areas here. Spatial computing. It's both a huge one for user experience and nearly full standardized. This is the start of the update. Visual fidelity makes experiences sharper, and its standards are solidifying fast. Facial expression and body lets avatar mirror real human movements, and it is still vendor specific. Interaction, generic controller and hand. These two interaction features have above average levels of both experiences impact and standardization maturity. Infrastructure doesn't affect end user much directly, but it highly standardized, so it makes OpenXR more stable for developers. In short, 2025 OpenXR is turning great user-facing features into industry standards while using robust standards to make experiences better. Spatial Entity Framework. This is the backbone of spatial computing, but built on 6 industry-ratified extensions. These 6 tools form a for-loop. Spatial Entity turn real-world spaces into digital data OpenXR can understand. Spatial Anchor pins virtual content to real locations with sub-centimeter accuracy, so your virtual monitor won't draft around. Spatial persistence saves the spatial data across app. Your AR furniture stays right where you put it. And the spatial marker tracking tracks QR codes to trigger or align the virtual content. The spatial plane tracking detects the real flat surfaces, so virtual objects sit on the table instead of floating through them. This framework doesn't just show virtual content, it lets XR understand and integrate with the real world. Vendor-specific spatial extension reflect the rapid maturation of OpenXR platforms and the ecosystem diversity. Focusing on 2 campus extension solutions, PICO Spatial Suite serve as the foundation for spatial entity capabilities and sensor accessing support and underlying functions for subsequent spatial features. The BD spatial anchor and sharing enable customer anchor definition management and across devices anchor sharing. Spatial scene provides access to scene scanning data with semantic understanding. Spatial mesh retrieves environmental mesh data, enabling occlusion effects and physical interactions for more realistic experiences. Android trackables grants access to trackable planes and environment objects. And the trackables marker supports tracking visual markers for process positioning in AR scenarios. Android Recast enables efficient re-intersection test against the environment. Devices anchor persistence supports anchor persistence across application sessions. And the content remains in the place where when the app is closed or reopened. This extension complement the general spatial entity framework, allowing different platforms to deliver more differentiated spatial extensions based on their hardware capability. Facial expression and avatar capabilities, with the goal of enable high-fidelity social presence in XR through non-verb communication. Vendor extension capabilities, facial simulation provides access to facial expression data on PICO devices, supporting the facial action coding system, blend shape, used in professional motion capture, allowing consumer-grade hardware to capture the fine-grained facial movements. Android face tracking enables the native facial tracking capabilities for Android mobile XR devices, standardizing the expression capture process on mobile platforms. It covers eye gaze, mouth strips, and eye-brain movements, and can even map corresponding emotional states. The core value combined with the body tracking, these extensions can build comprehensive avatar systems by capture the real-time macro expressions. The avatar fidelity of consumer-grade XR hardware now approaches that of the professional motion capture equipment, making expression transmission in XR social interactions more realistic and natural. Interaction. Let's talk about the controller interaction, a huge pain point for developers. Till now, the magic here is balancing the standardization and innovation. Generic controller, this is the universal fallback profile. It standardized how triggers, grips, and buttons work across all controllers. No writing customer code for Quest, PICO, or Vive controllers. One setup works for everyone. But vendors still get to innovate. Logitech added Stylus support for the process 3D modeling and drawing. Meta let controllers work without being held. ByteDance added support for PICO Ultra controller. We also fixed the gaps in input registry, so even niche controllers work reliably. Hand interaction is getting smarter. Two big updates here. Hand interaction. This evolved from Microsoft only feature. Only feature to multi-vendor standard. That means hand tracking works consistently across devices. No more, this hand gesture only works on brand X issues. Meta hand tracking micro gestures add a subtle pressure gesture like different pinch styles or single finger inputs. You can grab a tiny virtual object with just your index finger, not your whole hand. This diagram on the right shows how we track individual hand joints. This level of precision is what makes these subtle interactions possible. Visual fidelity is make or break for immersion. So 2025's OpenXR upgrades this in 3 key ways: the eyesight fidelity, performance, synthesis, and pipeline clarity. Eyesight fidelity extensions like random model let apps to load Zhao models that match the user's actual hardware exactly. So their virtual controller looks identical to the one they are holding. No more, this doesn't look right disconnect. Performance synthesis. Use motion vectors to smooth out visuals, even if the frame rate is steep, so the experience stays fluid, even when the hardware is working hard. Pipeline clarity. We update sRGB color rules and graphics banding to eliminate confusion. And developers spend less time debugging rendering glitches and more time building great experiences. And pass-through is now seamless thanks to 3 optimization. The loader mechanics, loader init properties, a multi-vendor tool that lets developers fine-tune how OpenXR set up, perfect and automated testing or CI or CD pipelines, interaction per session. We clarify loader API rules. We clarify the loader API rules to reduce edge case bugs. Different implementations now behave consistently, so developers don't have to hack around device-specific quirks. Runtime behaviors, input source definitions, we split API level input sources. So we split API level input passes from runtime level input sources. So complex controller setups are easier to manage. MND head list. For server-side or non-virtual apps, we remove the need for graphics check. Initialization is faster and simple. Finally, we solve huge UX problem, freezing UI during a long spatial tasks, like scene scanning or mesh generation. Here is the issue. These tasks are slow and resource heavy. Users often stare at a stuck screen, wondering, is that work? BD feature progress lets app to track the completion percent and estimated time remaining, what phase the task is in, and even cancel the task in the middle process. This works across AR, VR, and MR devices, so users always know what's happening, and the UI never froze. Oh, okay. That's all. Thank you.
Cool, thank you. And we're going to have time for questions at the end of the session, so please keep your questions, and we'll bring everyone up for that. Next up is Peng. Do you want to come and give us an update on spatial perception? A key area.
Okay, good morning, everyone. How are you? Are you good? Yeah, great. Okay, my name is Peng Liu, and I'm the OpenXR tech lead of PICO from ByteDance. And today, I'm very glad to be here to talk about something about the open standard for the next-gen spatial perception. As Neil and Ming mentioned, they both mentioned the spatial entities, and I will dive a little bit more detail about the spatial entities. So, first, let's see what is spatial perception in XR. At its core is to sense, analyze, and interpret the spatial information about the physical world around us. So it can be abstracted into three steps. So the first one is the sensory data capture. So the XR devices can capture the raw 3D data by its like cameras, radars, and all the built-in sensors. And then is the data processing, usually with some algorithms, and this is to turn the messy data into something that is meaningful, like detecting a wall, a ceiling, a floor, or a table. And the last one is the spatial representation. And this is to turn those insights into something, into some data that can be used by the applications. For example, like the triangle meshes or the semantic labels or something like that. And we can see, let's see some real-world use cases for the spatial perception. The first one is the scene understanding. So imagine you are in a MR game and your character just walk on the ground and cannot walk through the walls. It's just rely on the spatial perception to detect the floor and the walls so that it can make the experience more natural. And the second one is spatial anchor. So imagine you are in a MR meeting, so you just place a virtual whiteboard on the wall, and the spatial anchor will keep the whiteboard stay there even if you walk around, walk across the room, turn around and come back, it will stay there. And after the meeting, you close the application, and even you can power off your device. And the next day, you have another meeting, you open the app, and the whiteboard will be still there. So that is the persistence. It's just extend the life cycle of the virtual object across the sessions. And the next one is the sharing. It can allow the developer to build multi-user or multiplayer experiences, and allow the user to share the virtual object, and so it can make the collaboration more natural. And the last one is the physics or the navigation. So the spatial perception can give you a 3D blueprint of the physical world, and that is perfect for the physics and navigation and all other features that need to respect the real world rules. So we can see there are many useful use cases. However, different vendors may have different APIs for the spatial perception, and so here comes the problem. Fragmentation. And now we have the OpenXR Spatial Entity Framework. It is the game changer, and it just changed the situation and unified the ecosystem. So it is created by the collaboration effort by both the hardware vendors and the game engines. And it is a cross-vendor and cross-platform. So that the developers can build once, and the app can run on multiple platforms without any modification. And it is also a unified and standard foundation, which means with this framework, we use the shared vocabularies, consistent APIs, and universal data structures, just like we all speak the same language, and it makes the collaboration and iteration so easy. And it used the entity component design with high flexibility for extending. So if you want to extend this framework with some new capabilities, you can just define this capability and the related component data, or even some configurations. You don't need to rewrite the code spec, just plug and play. No matter the capabilities, vendor specific capability or cross-vendor capability. Okay, so before we dive into the details, we can just see some key concepts of this framework. So the first one is the spatial entity. It is usually an ID for a single object, like a wall, a table, or a chair here, just like the first row in this table. And the spatial component are the property details of the object. And one entity can have multiple components on it, like the first column in this table, like the bounded 2D, mesh 2D, bounded 3D, mesh 3D, or marker. And spatial capability, it is a runtime ability to provide the spatial entities with a set of component data, like the plan tracking, mesh tracking, and mark tracking this table. And the spatial capability feature, it is the configuration or configurations that the developer can make to the specific capability. For example, you can set the LOD for mesh tracking so that you can get different type of meshes. And next one is the spatial context. It is a container for everything, including the spatial entity, spatial capability, features or components. And the snapshot, it is just a data copy of the entity and the components for a specific moment, and it can be reproduced by the discovery and the update. So the discovery is to scan the environment and find the spatial entities in this in the physical environment. The update is to sync the changes of the component data for some selected entities. So I will give you a simple example. So I can create. Okay, let's see some simple steps first. Okay, so how to build the immersive experience with this framework? You just need to follow some simple steps here. The first one, you need to create the spatial context with some enabled spatial capabilities, some enabled components, and some configuration if needed. And then you can just create a discovery snapshot to scan the environment and get all the entities you want. And then you can create the snapshot for the component data. And then you can choose some of the entities you are interested in. And then you can create the update snapshot for the selected entities. And then you can query the components from the update snapshot. You can do that in the frame loop, like in every frame, to get the latest change of the entities. So I can give you a simple example here. So like I can create a spatial context with I can enable the spatial capability like the plan tracking here, and I give some enabled capability components like the bounding box 2D meshes or semantic labels. And then I can create a spatial discovery snapshot so I can tell the runtime, so, oh, hey, scan the room for me and give me all the plans. So the runtime will scan the room and it may give me many entities like the floor, the wall, the ceiling, or the table. They all have plans. And maybe I'm only interested in this table. So I can select this table and just create the update snapshot for this table. I can ignore the floor, the wall, or the ceilings. And in every frame, I can create the latest component data of this table. And then I can do everything I want based on this table. So like I can put a virtual toy on this table or something like that. So the ecosystem is already booming, and we have already released some of the cross-vendor extensions in OpenXR. The first phase released in 1.1.49, and the Spatial Entity is the base extension, and others are built on top of it. So we have spatial anchor, persistence, operations, apply tracking, and market tracking. And they are already there in the spec, and you can just use these extensions to build your immersive experiences. And there are also some new capabilities coming soon, like the mesh tracking, object tracking, image tracking, and room tracking. So, okay. So let's see some PICO support for the spatial perception extensions here. So we have our vendor extensions that released in 1.1.47. We have our ByteDance extension like the spatial sensing, anchor sharing, plan, mesh, and scene. So that means you can build the spatial experience with these extensions in PICO's device. And we also actively adopting the cross-vendor extensions. And they are coming soon in our next release, maybe. And we have implemented the spatial entity, anchor, persistence, operations, and plan tracking. So that means your OpenXR built application can seamlessly run on PICO's device without any modification. So we are also very honored to be the first vendor to provide the experimental cross-vendor implementations for the spatial entity framework, and then we collaborate with Go.Engine to validate the cross-vendor extensions for the first phase, so it can be released smoothly. Okay. So if I know the OpenXR API are mostly for the native developers. So if you are engine developer, like you are using Unity or Unreal to develop the XR application or games, you also can use PICO's engine SDK for the spatial perception. We have wrapped all the spatial capabilities in the easy-to-use engine SDK. Like we have spatial anchor, persistence, sharing, mesh, scene, and plan, and they are all there in our XR SDK. So I think the spatial perception is no longer it's no longer nice to have in XR. So it is the reason that people choose XR. So I think the open standards like the OpenXR just reduce the frustration and allow the developers to more focus on the user experience rather than the adoptions. So I believe we can build a future for the users, for the developers, and for the XR industry we allow together. Okay, thank you very much for your time.
Thank you. And I'd like to thank PICO, not just for supporting us here at SIGGRAPH, but just in general. ByteDance and PICO, you do a lot to help OpenXR evolve. So thank you for all the work that you do. And if you can enable me with access to that demo, that video, we can share it at the end.
Okay.
Yeah.
Sure.
And maybe, yeah. So, next, Weiqi from Rocket.
Okay, it's my honor to be here, and it's the first time representing Rocket be here in SIGGRAPH to share our minds in the experiencing for the past 10 years. We are working on the AR hardware and software. So today's topic is to bring OpenXR and WebXR to everyday glasses, and Today we're building the spatial application is still spreading hard. You can see we develop a lot of hardware, and of course we're focusing on the optical see-through glasses. Like glasses, it's not like a headset, right? So it will be more challenging. So developers will have navigate a lot of XR landscape product, different devices like different SDKs or hardware specs, APIs, and engine folks. A lot of stuff. It's like a fragmentation that slows innovation. So, and it creates cost for the porting everything. So, we are always thinking about how to make it easy and make it good for the developers. And yes, that's it. That's why we're here. And so, at the core of this problem is what we call the spatial divide. So. You can see we separate the XR AR part to two worlds. So one is a web world, right? So it has fast iteration and massive developers based, right? We have a lot of web application developers in the world. But it's constrained by 2D viewports and missing depth on semantics. So in this case, we try to make the 2D web to the 3D. Okay. So another side is we have a native 3D engines. So it has powerful rendering and it has full spatial control but high batteries to entry. For example, you have the basic knowledge about the Unity, Unreal Engine, and you have to know about the 3D spatial part, and it also has a slower UI integration as well. So in this case, we have to face this challenge, how to solve it. So today, developers are often forced to choose one world or the other, right? So it's divided. So we want to bridge it, how to. So the solution at Weiqi, we don't believe that developers should have to choose. So powered by Yoda OS Master, our spatial computation US. So actually all the glasses, even this AI glasses and the AR glasses, we're running with the same OS. So we built the unified platform based on open standards, especially like OpenXR and WebXR. So this is not about forcing the single path. So you can see we have two different LAN, and it's a native LAN and a web LAN for different developers. But we try to enable two powerful LANs on one solid foundation. It's OpenXR and UDOS. So open standards are the bridge. Okay, so you see everything starts with a single OpenXR foundation. So on top of the foundation, we support two different paths. On the web path, so powered by WebXR and the JSAR. I will talk more about JSAR. So it's optimized for the rapid iteration and scale. And the native path, we're familiar with that, right? So it's powered by OpenXR and the Unity and the Unreal and Godot, something like this, or the engine like this, optimized for high performance experience. So, and more important, these paths can combine together. So the blended paths. Actually, we also figure out the solution like you can embed the JSAR engine into the library directly into the Unity project. So in this case, you can run in like a 3D engine in your devices, also embed a web browser-based framework to run the web app. So it's a new thing for the developers. And it's the tech part. You can see it is how the platform comes together technically, right? So they're both the native engine, Unity and Unreal, connect with the Weiqi OpenXR plugin, and build on our native OpenXR SDK. Also at the same time, the JSR, our spatial web browser engine, run web content natively in 3D space and on the same OpenXR runtime. So in this case, whether you build it with HTML, CSS, or JavaScript, or with Unity and Unreal, you can access in the same baseline, the OpenXR SDK. So, yeah. Okay, let's talk about the JSR first. So JSR is a spatial web spatial web browser engine, so built from the ground up. Instead of adapting the 2D browser into XR, GSL rendering traditional web content, like we are familiar with, like HTML, CSS, JavaScript, directly into the true 3D coordinate space. Every element in real has a real depth, position, and spatial properties. And we choose the redesign over the retrofitting because the performance simply so make it simple for the developers, and it's a true mixed rendering demanded. So let's show some features about GSLR. So GSL gives the developers something very powerful, and it's if you are familiar with the web technologies, it's easy for you to develop the native 3D the behaviors in GSLR. The spatial DOM and with true depth ordering, and we also support like a unified graphic pipeline for HTML and WebGL content, and it support automatic serial rendering because for the glasses, most of the glasses are serial rendering, right? For dual eyes, right? Dual solution. So we also support spatial audio and input with XR native import matting. So another thing is an aggressive passion for high performance. It's a for web XR capability. So for all the web application developers. So let's see what we can do. So what's this enable in practice? Actually, we apply this in the rich spatial dashboards, something like this, or interactive content panel, or 3D access browsers. So in this case, you can open the browser and then drag the 3D model into the reality world. So it's very easy for the developers to embed the mix the digital content from the browser to the reality world, right? So, and it's more important, the GSLR can be embedded directly into the Unity projects. So you're familiar with the Unity, and you can bring a GSLR framework into it. So the native 3D scenes combined with the web-powered UI. Yeah, for some application, you have to deploy a more adaptive UI compared to the traditional native UI in Unity. You can use a web-based, web-powered UI. So the best for both worlds, so as we mentioned. Yeah. Okay, so, and the next part is another word, right? So we experience the need to maximum the performance. So OpenXR also becomes the key. So Rocky OpenXR plugin provide a direct and standard-based interface to Yoda OS master, spatial computation stack for both Unity and Unreal engine. And this ensures the portability, the developer's familiarity, and the long-term maintainabilities. So for our developers, you have a standard based, and we also have a direct hardware access. You can get the information and the info specs from the hardware, and you also have a rich interaction. We offer the robust tools like a virtual reality, a real world interaction like a gesture or SLAM as well. Okay, let's see what the features we offer for this part. So, okay, through the OpenXR, developers can access the essential spatial building blocks. Maybe some of the XR developers are already familiar with that. So we support like 4, 6 DOF or 3 DOF tracking and plan detection, image recognition, and controller and articulated hand interaction. And also, more importantly, we offer the device and the SLAM and the camera data to the developers to help you to build more immersive applications. So these are the features that immersive worlds are built on. And it can cross the engines and expose consistently. So the last part, so to summarize, so we believe the OpenXR gives us a solid system foundation, and WebXR and GSL bring speed, scale, and accessibility. And the Unity and Unreal deliver performance and virtual depth So together, actually, they allow us to build a developer ecosystem for future and around the open standard offered by XR, the WebSR, and shape the future of the spatial competition together. Thank you for sharing this.
Great, and everyone kept on time too. You guys are awesome. So do you want to come on up and we can see whether there are any questions? Any questions for any of the presenters? Yes, over there.
So I have a question for Mr. Yi. Okay, so you mentioned that there's an extension of random model, right?
Yeah.
So I'm curious about what's the relationship between the random model API and the low-level token, for example, rendering API.
So it's different. The low-level token it's just render the content you want to. The random model, controller the model, it needs to reduce the developer's burden. If you want to know the controller model, the model is exactly what we need to use a lot of work to others. We don't need to run the model without writer. We don't need to write the render code. That's the way to do the API. We can show to the model.
So it's up to the runtime driver's decision which API, rendering API to use. It does not expose to the developer.
Yes. It doesn't expose to developers.
By the way, so does this render model API place any constraint on the, for example, performance constraint on the low-level API?
Yes, but I'm sorry, I'm not sure exactly because it's based on the platform your application run.
Thank you.
Thank you. Any other questions? Yeah.
For about JSAR, is it support only Rocket's device or any mobile phone?
So actually, it's you can get more details in the GitHub. It's an open source project, so we can you can try it on your devices. So we are trying to contribute to the more devices supported, and welcome to as a contributor for us to contribute more things because web is from 2.0 to 3.0, so it's a lot of changes. So we trying to make more. It can fit more and more devices in Xbox industry. Thank you. Good question.
Yeah, back there.
Will it be for the future OpenXR versions? Will it be able support for the new version?
OpenXR, you mean the OpenXR will support HoloLens?
Yes.
It's not designed by the OpenXR. It depends on the manufacturer.
Okay.
You mentioned which version? The second generation or first generation?
Second.
Second generation. From a point of view, from a knowledge, I think it should be support, but you can test about the specs for SDK for this problem.
Yeah, I got another question for Mr. Zhao.
Yeah.
So you showed that for JSAR there will be some new feature on Gaussian splitting. So I wonder if there any progress on that?
Yeah, actually, it's a little complex process. So I sent you the SDK documentation for this. Actually, we are trying some e-commerce project. So for that, like an Alibaba or other online commerce. So you have to show the 3D model pop up in front of your eye and put it into the reality world. So it's working with this brand solution. Yes, I would say related. Yeah, you can check that out. Yeah.
actually, I'm new for this area, but I do some eyeball checking device and everything. Just like the same different activity. OpenXR got eyeball checking API area. So is that how this doing in your area? Or I'm not sure which one.
Here is the eye tracking.
I check grace check and high grace. Yes.
You mean how to track your eyes?
No, I understand that, but how that you using that kind of eye tracking interface for application and your device that can provide that kind of, because some students need that kind of features in their study.
Actually, there are two directions. The first one is you can use the eye tracking to express your expression.
But I mean the device, how good is this, and how application easy to use the OpenXR to do the eye tracking with the application.
The first one, the device should support the eye tracking. That means it should include the eye tracking camera and LED light, so the algorithm can catch so the algorithm can detect the eye tracking. So and the user then the developers can use the eye tracking APIs to get the recast, and you can use whatever you want that has the interaction and or the forward rendering.
So the application can include OpenXR to the
Yes.
yes.
Maybe all of you. So it is really nice to have a unified platform and standards for everything in OpenXR. But if Apple doesn't comply, because it's a huge platform, right? Yeah. Is there a chance that they will collaborate?
Good question. I think it's a good question, and we face the fact exactly. And I think users use iPhone and users the Android phone. And a lot of people, maybe a large people, a large majority people use the Android phone. So I think the AR market is maybe the same like phone.
So actually, it's always a problem, right? It's a question like for centuries, right? So it's an open source and a closed source. Right. So if you are working like us, we're working on like open source ecosystem. So our mindset is contribute more, get more. So we will advance all kind of devices possible in the future, and we contribute even like OpenXR, like Android XR as well, right? So we try to make any features for different devices. It's different mindset. But for the ecosystem from Apple, they offer one feature for their products, the Apple brand products. So even those guys from PICO and from Weiqi, but another role in this industry, we contribute for the OpenXR. So we both are players in this ecosystem. We are more than us, so we have more players. That's well in the rest of that. So Meta as well. So we both, all of us, contribute what we can do for the open source community. It's more important. It's different mindset for the commercial, right? Yes, but I think the problem will be lost for another century. So, okay, another thing is I think we can make some noises for the users, and users try to embrace more open source project, because maybe with vibe coding, everyone can be developers. Everyone can contribute. So the future, as I mentioned, the future is a spatial and open. So spatial means we make more connection with physical world, and open means everyone can play as a contribute for this ecosystem. So yes, it's your choice, not our choice.
But it's a problem that's not just XR. I mean, it's the 3D APIs. So Apple has Metal, and most of the rest of the industry uses Vulkan, and there's of course DirectX 12 as well. The way the industry solves that for the developers is open source layers. So Molten VK, layers Vulkan over Metal, and you get portability. There's DXVK to layer DirectX 12 over Vulkan as well. So I think it's an interesting question whether the open source community will come to the rescue of developers in a similar way for XR. I think it maybe is a little bit early because things are still kind of settling down, and there are some complexities, I'm sure, but I wouldn't be surprised if we find a Molten XR or something at some point to layer OpenXR applications over Apple hardware, maybe.
Sorry, I was late. I missed the previous, so I just have the questions from my daily works. So the beta in this previous year for Oculus already opened the camera API, but I know that for the PICO it's only open for the business glasses. For the commercial, they haven't opened up. And I heard that the new version of the PICO beyond the PICO 4 Ultra is coming maybe next year. So I'm just wondering, is there any plan to open it up for us to explore more?
Yeah, very good question. I can answer it. So for the camera, for the pass-through camera access, we are planning to open it, not only on the next generation device. Currently, we are planning to open it on the PICO 4 Ultra. Maybe next release, we will open the camera access.
That would be wonderful. And another question from my daily work with WebXR is that I've been testing a lot of frameworks in the current market, and I realized that this not really supports a lot of browsers. Sometimes it has conflicts in between. Is there any solutions to?
So that's why we build our own browser. So we've been working with OpenXR for many years. So there is a fantastic browser called Firefox, right? So it's supporting WebXR very well. And but so you need to input a lot of the cost and time and money into it to integrate it. So that's why we are here. So we are the top player in the industry. We try to run some open source project, and we welcome all the contributors to contribute the new things. But we have very limited power to push it forward very fast. So as you mentioned, there is a lot of question challenges. That's why it's a very limited number of browsers supporting WebXR. So yeah, but anyway, we are working on this. So go to the GitHub, give us feedback, and try to build your own, maybe, right? So this is the only thing we can do for the community, right?
So where can I download the presentation slide?
Yes, all the presentation slides. Actually, I can go to the end. If you go to the Kronos website, there's a SIGGRAPH page on the website. We should have all the slides uploaded, hopefully by the end of the week. They were fresh this morning, so they're not uploaded yet.
Maybe you can share some spirit of community, so all those guys can want to be a contributor for the community.
Yeah, so I mean, a lot of the development for OpenXR is done on GitHub. So you can, again, go to the same website. You'll find all the links into the various repositories. We very much welcome developer feedback on there. Any company is welcome to join Kronos if you want to get directly involved. If you want to get involved, please reach out to us. There's some email addresses here. We'd be glad to get you involved. We're setting up some local China meetings too, because we realise that a lot of these meetings are in English and in time zones that are not that friendly to Asia often. But we're setting up a series of meeting forums here in China. We started with some of the compute and GLTF, but there's a lot of interest here. Maybe we should do it for OpenXR as well. We can have some local China meetings. Would be great to get more feedback and input from the China community. Any other questions?
If you have a question, you guys also can link us for the messages if possible. Yeah.
I know we're a little over time, but I have a question. If people, JSAR is awesome now because it's bringing in the 2D into the browser. Do you a metaverse browser though in a slightly longer term, where we're genuinely compositing multiple users, multiple services into a 3D environment? Do you think the web stack will we be able to evolve the web stack to do that, or will we need a new web stack? What's your view?
It's hard to say. Actually, from a point of view, I think this depends on how the developments for like networking and rendering quality and frequency and latency.
Yeah.
Because if you want to put multiple person sharing the same 3D spaces in real time, so it's a little bit challenging for the portable devices.
Yes, right.
So also we need to depend on the chip and efficiency for the computation.
Yes.
Like MPU or maybe with AI will help you to save a lot of energy, right? So let's see. But I'm not. From my point of view, I think it's not about the standard part. So we are trying to figure out what's the best standard for the next level of the web. Right?
Yes, that's right. Yeah. I think it's an interesting discussion. And to that point, there's a Metaverse Standards Forum BOF. We'll be discussing this. That's at 3:00 this afternoon in 221, I think. Yeah, just next door. So if you like the metaverse, then come on to that BOF. So that's great. We're out of time. Thank you, everyone, for attending, for the great questions. Thank you again to the presenters.